Hi again. Yeah. So before we did questions 48, 49, 50. Let's look at 51 and then hopefully today I will finish all the remaining 10 questions and just upload everything. So you're gonna have the entire solution for this year in my YouTube channel. Okay. I'm just reading question 51. Hopefully you have the test PDF open on your device. Which of the following is the solution of the inequality? The following inequality: x squared plus the absolute value of 4x plus 3 um, over 4 minus 3x is greater or equal to 0. Um, I have no idea. So I really don't, seriously. So yeah, let's just try it out, okay? Let's try it out. Mm, The meaning of having an absolute value is that no matter what happens, even if we have a negative number, the absolute value makes it become positive. So this is the just so you understand what it's about. Okay. So I actually paused the recording to go look online. I started to see a YouTube video about that's similar to what we're doing, maybe a little easier, but the guy looks seems to be explaining very good. And I'm gonna just do whatever he said, and I'll explain to you why it makes sense, and then hopefully, again, hopefully uh, we manage to finish and get to the solution. I will, of course, make sure that this is what happens. So first of all, what we need to do is we need to isolate the inequality. We need to isolate the absolute value term from the rest of the inequality. So yeah, what we do here is blah blah blah. Yeah, we'll just multiply by everything that is here. Um, and no need to change the sign. Usually we need to change the sign if we multiply by something negative. So I don't know if this is negative or not, but currently we're not going to do anything. We're just going to have x squared plus the absolute value of 4x plus 3 is greater or equal than 0. And now we're gonna move x squared to the other side and just leave um, the absolute value by itself. Now what we're gonna do is we're gonna separate this into two different uh, equations or inequalities to solve. First of all, we're just gonna write the same without the absolute value. 4x plus 3 is greater or equal to minus x squared. This is number one. And number two will be in yellow. 2, um, 4x plus 3 is uh, smaller or equal than x squared. What I did is I'm just saying that we can either not change anything and just disregard the absolute value. And maybe if originally the term was supposed to be negative and the absolute value made it be positive, then it was supposed to be smaller than whatever, then I will change the sign here. So both of them become negative, or what I hope you understand. Again, because when I have an absolute value, I don't know if, for instance, I have minus 3 inside the absolute value. When I do the absolute value on it, it's going to be um, plus 3. So I don't know initially what I had. So I have to look at the two options of whether it was positive, sorry, or negative. Let's try to solve it. Let's see if it works. Let me put everything on the same side here on the red. X squared plus 4x plus 3 is greater or equal than 0. And now I can use a trinome. I think this is the translation. In Hebrew, we say trinome. So trinome, I don't know, whatever. But you will see what I'm doing, so you will understand. I'm just separating this to two numbers that can help me. X squared plus x plus 3x plus 3 is greater or equal than 0. You see, instead of 4x, I just separated 1x plus 3x. Now I can extract the mutual term here and here. So I have x plus 1 plus 3, um, x plus 1 greater or equal than 0. And now I have x plus 3 times x plus 1 is greater than or equal than 0. Now, in order to have this multiplication give us 0, we look at this, look at what I'm doing here. I'm gonna need, if this is 0, we're gonna need x will need to be -1 or -3. So if x is -1, this is gonna be canceled out, becomes 0, not canceled out. It's gonna be 0, so it's gonna be equal to 0. And then here also, if this is -3, it's going to be equal to 0. Now, when is it larger than 0? So we can just plug in numbers. Let's say that I put x equals 0. X equals 0, then this is 3 times 1. It's going to be larger than 0. So in this area, we're okay. This is larger than 0. Let's put in between. Let's put -2. If I put -2 here, this is going to be positive, this is going to be negative. So we're going to get a negative number. So this is not good. And this is, again, it should be good. You can make sure that I'm right. And then what I'm saying is that if we have numbers that are either -1 or larger, or -3 or smaller, the inequation is going to be fine. You can try to plug in numbers and you will see that you get a correct term. Again, example I showed you before. Let's take a different example, -4, for instance. -4 here, you will get -1. Here you will get -3. You will multiply them and you will get a positive non-zero number, will be absolutely fine. So here, the solution for this inequation is going to be x is smaller or equal to -3, and or x is larger or equal to -1. Now let's go to the yellow term. Let's again move -x squared to the other side. No, let's move all of these to this side. So x squared is larger than, so before, let's put these here because I moved them to the other side, and let's keep the inequality directed at x squared. I hope I'm not confusing you guys. Yeah, and now we have x squared, maybe minus x minus 3x minus 3 is greater or equal to 0. X minus 1 minus 3, x minus 1 greater or equal to 0. X minus 3, x minus 1 is greater or equal to 0. So we have exactly the same thing as before, only the plus minus signs here. And I think what is going to happen here is that um, we get the opposite of what we obtained before. Let's look at an example. Let's try to plug in -2. If I plug in -2 here, this is -5. -2 here, this is -3. It's multiplication, it's going to be 15. It's going to be fine. If I put um, oh, no, wait. What cancels out, I'm sorry, I'm really sorry, but let's do let's do this again, like I did before. I don't know what happened to me. This is 0, this is 1, and this is 3. Why? Because 0 is 0, whatever, for reference, and 1 and 3, um, they're the numbers that are gonna make this inequation becomes 0. So 0 equals 0. So this is the limits of the areas that I want to test out. So yeah, so now let's try to plug in. Okay, I saw that this gives me, I took a number here minus whatever, it give me a positive number. So I think this is great. So this here is going to be great. And if let's try to put something larger than 3, 4, for instance, 4, this is going to be positive, this is going to be positive, this is exact. Again, this is great. And just to make sure, let's try to put 2. If I put 2 here, it's going to be negative, 2 here, it's going to be positive. So in total, it's going to be negative. It's not good. So I have this, so I have both of these. And now it's hard to see. So let me take this plot and put it underneath to see the mutual x's that are allowed. Um, yeah, um, so this is 0, this is -1 and -3, and I'm gonna, yeah. And again, let me use the red line to show you that this is good and this is good. Okay, so I think, and we need areas that are mutual. So I think that look at the mutual areas. This is a mutual area. This is a mutual area where the two lines are supposed to go to, and this is the mutual area. Oh my God, I think I have a big mistake. It's too much. It's too complicated for an IMAT question, but let's find out. So so I think that the overall solution is that x is smaller or equal to -3, or x is larger and equal or smaller or equal to -1 and 1, and x is larger or equal to 3. And if I look at the solution uh, for the inequation, so uh, yeah, it's real x with x is smaller than 4/3. Okay, what can I say? Hey, let me know if you like what I'm doing. I'm showing you everything that I do. I think what I did, the technique was good, but I think, I Googled a little bit, and I think what I did, I'm going to try out something different. I think what I did is I completely ignored um, the denominator of the term. And I think this caused maybe a misunderstanding. And I told you it looks like it takes forever to solve this, so something is wrong. Instead, let me do the following. Let me separate these into two different fractions for 1 minute, okay? Let me do this. X squared over 4 minus 3x is plus um, yeah. So you see this? This is um let's just do it step by step. 4x plus 3 over 4 minus 3x. Okay. This is greater or equal to 0. Let me move this to the other side of the equation. So 4x plus 3 over 4 minus 3x is greater or equal to x minus x squared. 4 minus 3x. I just moved it to the other side. And now I think I know what I want to do. I'll explain. Um, yeah,